Merhaba from first year CSE and I'm giving a presentation on the topic electronic polarization. Outline of my presentation is introduction, electronic polarization, mechanism of electronic polarization, calculating electronic polarizability, and finally conclusion. Let's starting with introduction. When an electric field is applied to a dielectric material, the separation of charge carriers takes place. That induces dipoles throughout the material. Whenever we are applying an external electric field to our dielectric material, then there is a separation in between electron clouds and nucleus. This process of producing dipole by the influence of an electric field is known as dielectric polarization. Basically, there are three types of polarizations. The first one is electronic polarization, the second is ionic polarization, and finally we are having dipolar polarization. So these are the three basic polarization mechanisms. Let us see what is an electronic polarization. It refers to the displacement of an electron cloud within an atom or molecule in the presence of an electric external field. So this phenomenon leads to the creation of electric dipole moments. Due to this electric field, the electron cloud and the nucleus moves in opposite directions. For example, while the electron clouds move in left direction, the nucleus moves in opposite to that in right direction. It leads to electric dipole that arises a dipole moment. So let us see what is a dipole, induced dipole moment here. We are having induced dipole moment. This is the equation for that, where alpha E is electronic polarizability and E here is of electric field strength. As we all know that dipole moment is directly proportional to this electric field, and by removing the proportionality constant, we will get this electronic polarizability alpha E. So mechanism of electronic polarization. So how does an electronic polarization occurs? We can clearly observe in this slide. Here, the primary mechanism of electronic polarization includes the displacement of electron clouds, the induction of dipoles, and the reorientation of permanent dipoles. In the displacement of electron clouds, the electron distribution is shifted in response to an external electric field. Induction of dipoles occurs when an external field induces the formation of temporary dipoles within a material. So in this image, we can see how electronic polarization occurs during no field, external field, and when external field is applied. So right side column is all refers to the field applied, while the left side is having without any external field. So we can see here in this the space charge polarization, all when the electric field is not applied here, all are assigned in a sequential manner. While when we apply some external field here, external electric field here, so these you can see all the electrons and positive charged particles are again disturbed, and they are in a different manner. How to calculate an electronic polarizability? We can be easily understood by this process. First of all, consider an atom of a dielectric material of nuclear charge Ze, which means plus Ze. The electrons of a charge minus Ze are distributed uniformly throughout the atom, which is a sphere of radius capital R as shown in a figure. So this is the atom considered. Then here we have given without field, how does it look like actually? Here charge density of charged sphere of radius capital R is equals to nothing but total charge of the sphere by volume. We all know that the volume of a sphere is 4 by 3 by R cube. As we are having the radius capital R, it is capital R cube. And here charge of a sphere is a minus Ze, which is taken here electrons of charge, that is minus Ze. So we'll get total charge of sphere as minus Ze. So we are sending these three up, and this is considered as equation 1. Why? Well, the external electric field is applied. What happens? Let us see. When an atom of dielectric is placed in an electric field E, two types of forces arises. The first one is Lorentz force and the second is Coulomb's force. What is a Lorentz force? Force which separates electrons and positive nucleus due to applied field. And coming to Coulomb force, it is an attractive force which is produced after separation. And at equilibrium condition, this both Lorentz force and Coulomb force are equal to one another. Lorentz force here is equals to the charge of electron and intensity of applied field. We all know that charge of electron is minus Ze and intensity of applied field here is E. Then Coulomb force is equals to charge of a positive nucleus into total negative charges enclosed in a sphere by 4 pi epsilon naught d square. Here we have taken d is the radius of a circle. The total number of negative charges enclosed in the sphere of radius d. So this is a formula charge density of electron into volume of a sphere. On multiplying these two, we will get minus Ze d cube by r cube. Substituting this equation 4 in equation 3, we will get Coulomb force as Ze into minus Ze d cube by r cube by whole divided by 4 pi epsilon naught d square. And after calculating this, we will get Coulomb force as this equation, and we are considering this as equation 5. At equilibrium condition, Coulomb force and Lorentz force must be equal and it also must be opposite. Lorentz force from equation 2 is equals to the Coulomb force from equation 5. On equating both this, Lorentz force and Coulomb force, we'll get an equation D equals to 4 pi epsilon naught or cube E by ZE. Considering this as equation 6, the displacement d of electron cloud is proportional to the applied field E. Now, the two electric charges that is plus Ze and minus Ze are displaced by a distance d under the influence of the field and form an induced dipole moment which is given by. This is the induced dipole moment epsilon E. Discharge of electron into displacement. Here we are taken that both the charges, electron charges and the nucleus are separated by a distance small d. So since this is the displacement small d, substituting the value of d from equation 5, we will get this. On simplifying all this, we will get alpha E, that is nothing but electronic polarizability is equals to 4 pi epsilon naught or cube is called electronic polarizability, which is proportional to volume. So conclusion of my presentation here is electronic polarization is independent of temperature. Electronic polarization occurs in all dielectric materials. It is proportional to the volume of atoms in the material, and also it is utilized in various applications including capacitors, sensors, actuators, and memory devices. It is essential for understanding intermolecular interactions, solvation effects, and molecular dynamics. So thank you, ma'am, for patiently listening to my presentation. This is Humaira Banu from first year CSE signing off.